tell you who I am.
Go ahead, Randy.
Yeah, Randy Jones.
Okay.
Gary Henderson.
Okay, I won't remember all this, but.
Al Wendler.
Oh, another Al, great.
And I'm Mike Mikowski.
Yes.
Felix Baltz, Lieutenant Colonel, U.S. Army retired.
Okay.
Dave Williams, ASU.
Frank Rucker, former NSS VP.
Oh, okay.
That's
Wow.
why you might.
Pat Bonchar, NSS Phoenix Chapter Treasurer.
Great. Well, my name is Al Anzaldua. I'm president of the Tucson L5 Space Society. And also I am running for Region 3 representative for NSS. So, do you have any questions about that? No.
When's the vote?
We can, who's going to, I don't know.
Actually, it will be in the summer. It'll come out on it'll come on the jacket of Ad Astra.
Okay.
So we need to do some mimeographing and I'm being bad.
I may ask you guys if it's okay with it, for endorsement, if needed. If I'm running unopposed, I don't know if anybody's running against me.
To go to Region C.
I heard maybe this is lady, a Puerto Rican lady might be running.
I'm sorry, what position you running
He's
for?
running for the board for
Region.
this region.
Yeah.
Okay.
And the thing is that
Who's the current regional?
Chris Carson.
Chris. How could you forget?
No, Chris.
Well, frankly, I get confused with there's all these different supposedly regional and chapter people, and there's like duplicity everywhere.
Well, this
Duplication?
Duplication.
Well, that's duplicity.
This
This redundancy,
Yes, are.
maybe a little duplicity too.
That's
Duplication, yeah.
Yeah.
one of the things that I would do if I get elected is I would start visiting all the different chapters, especially besides you folks, and getting input from you folks.
Welcome, welcome.
I would be very interested in visiting the Texas chapters. Because now I heard SpaceX is going to be having a launch, working on a launch area near Brownsville, Texas. And Blue Origin's got one somewhere in Texas that they're working on. So, and of course, there's a lot of NASA stuff going on in Texas too. So, I would like to visit all, and I have relatives there, so I can go ahead and.
You just want an excuse to go to Texas.
Yeah. Well, is that one other thing?
Well said.
I think it's important to bring Mexico into this.
Sure.
So, I speak passable Spanish, so I would probably
There was
do that too.
a chapter in Mexico City at one point. I really don't know what happened to them. I mean, they probably, like most NSS chapters, come and went, but there wasn't NSS present, same as in Canada. And they were actually pretty strong in Canada at one point, but they faded.
Yeah.
And now, Australia had a good lot of chapters and.
Well, I figure, I was shocked to find out that all of South America and Mexico, Central America is in this region. But no one's, as far as I know, no one has really developed.
You need to take
South
something. The lady who is running the Brazilian chapter, she was quite a big.
Really? Well, and also the Puerto Rican, I want to get the Puerto Rican folks in there. I have a stepson who's Puerto Rican.
Well, the
And,
the folks who went on the AIAA tour to the lava tube here recently are, seem like prime candidates, very interested. So if you have a list, you guys might want to shoot the list.
Yeah,
Because they're on their own basis.
when I'm on topic,
I'm off topic, I apologize.
Yeah, well, I haven't been elected yet, so. But I just want you to know what my intentions are. Because I think there's,
So you're
there's
promising
some
us
sort
is the moon and Mars.
Well, okay, but today we're going to talk about cis-lunar telepresence. And I guess I don't need that since I don't have one anyway. Can everybody hear me okay?
Sure.
Yeah, that's fine.
Sounds
All right.
good.
This is a generic, I just put this together. I had 3 other talks I put together. So it's fairly long, but if you have a quick factoid to throw in, or a quick, like if you want me to repeat something, or if you want to correct me, go ahead and do it real quick. If it
Except
gets
for
to be a philosophical discussion, we can do that afterwards, okay? And I hope, who's going to be at lunch with me later on? Anybody here? Okay, great. So, and gentlemen just walked in, what is your name?
Val.
Val, pleased to meet you. My name's Al. Rhymes with Val. It's next to the other Al with the white hat, so hope I can remember that. Okay. So as I said, this is sort of a generic talk. You folks can help me, with your input. I would like to do a version of this talk at ISDC and then have another version for people that are not space geeks. So here we go. This is all about cis-lunar telepresence. And I'm going to hope to persuade you that this is a key to solar system infrastructure, starting with the cis-lunar infrastructure that I hope we're going to be seeing develop step by step. First, I'd like to give a definition of cis-lunar space. I can tell you right now it's a misnomer, because cis means this side of. So this side between the Earth and the Moon, all this is cis-lunar space, which means that L2 technically is in trans-lunar space. And same way with whenever things are orbiting around here, they're not technically in cis-lunar space either. However, because people keep talking about cis-lunar space being all of this stuff, I'll just go ahead and go along with that. Notice that this is these approximate 61,500 kilometers. That's an important metric that and the importance of it we'll get to shortly. We're going to be talking about telepresence, so I thought, God, we should at least define it. So this morning I added this slide. Telepresence is the extension of human cognition and dexterity through telerobotics into environments too extreme, hostile, or inconvenient for humans. And the inconvenience could actually be that it's very expensive. So let's look at some of the context. We have a very remarkable context in space development right now. We have drastically falling launch prices. For instance, these are just to LEO, low Earth orbit, but there are analogous drops going beyond low Earth orbit. So if you add up all the costs of the space shuttle, you find out it's $27,000 per pound. Okay, it's 11:30 now. I want to keep track of the time. United Launch Alliance has got a couple of commercial launchers. Although they are subsidized to a tune of $1 billion a year, still, you can call these commercial for our purposes, I think, because they have their own skin in the game. They developed these without micromanagement from NASA. So their prices hover around $6,000 per pound. And there's a big drop then to the Soviet Proton, and another drop to Falcon 9, SpaceX. And the advertised price for SpaceX Falcon Heavy is below $1,000. And you see Elon Musk making noises about, oh, I think we can get down to $100 a pound. But we'll see. That would just be astonishing if you could even get close to that. So another piece of the context, space development context right now, is that we have drastically falling space development costs. And I don't want to insult your intelligence by reading all of this, but basically $9 billion was what was spent on the Constellation program to develop the Orion spacecraft and Ares 1 launcher. That program is canceled. No spacecraft or launcher was produced. NASA paid through its, what is it, the commercial, I forget, it's the one, not the crew, not the
Commercial cargo services.
You're right, commercial cargo. $336.7 million. We got we taxpayers got 3 Falcon 9 flights from that, including construction of 2 Dragon cargo spacecraft. SpaceX is developing its Falcon Heavy launcher with no taxpayer money. Okay, so, and you can see NASA, for $336 million, they can't even construct a launch tower. I'm not bashing NASA, by the way. NASA's really important. I wish they would double. The budget just came out for NASA, $17.6 billion. It should be double that. I'm just talking about what some commercial launchers can do and what, as opposed to NASA doing that work instead of other work like research and development for things that the private sector won't do. Here's another thing that really virtually brings down the launch cost, and that is now you see CubeSats, what are 4 inches on a side. These are spacecraft, real spacecraft, and recently, and you can launch a lot of them. You know, a pound's worth goes a long way. So recently we had a launch. U.S. Air Force, with 1 rocket, launched 28 of them into orbit while launching a heavy satellite also in orbit. We also have game-changing advancements for low communication latency sites. All right, we'll talk a lot about that. One game-changing advancement is the high bandwidth communication is accelerating development of that. High bandwidth being over 300 kilobits per second. And advanced telerobotics, which we're going to see a lot about. When I say telerobotics, it's important to understand that it incorporates robotics. You will hear people call things robotic. For instance, they'll say, oh, the arm, that Canadian arm, you know, on the ISS is a robotic arm. Really, it's not. It's telerobotic because there's an operator behind it. However, a lot of the new telerobotics systems that are coming about incorporate robotics. That is autonomous machine operation. Telerobotics is with an operator. It incorporates, you know, for instance, you can have a boom come out, right? And if it gets within a certain distance, it's operated by an operator. It gets to a certain distance, and it will automatically close. Well, that automatic part is robotic. So you can have these two things together, working together. Same way with targeting, if you're in a drone. You lock on, the operator does it maybe, but then it's done automatically after that. Okay, so what's happening on terrestrial applications of telerobotics? Here you got surgery going on, mining. This is off-site mining, underwater work, repairs, and so forth. And the military, of course, uses a lot of them. That was for explosives, to deal with IEDs and so forth. The Korea Institute, wow, they're testing this thing, this crabster, and it's amazing. 6 legs and, you know, grippers, the whole thing. It's something out of science fiction. They want to investigate and recover from shipwrecks. You know about drones, military drones. And the U.S. Air Force has a reusable X-37B space plane, which just passed 1 year in orbit, and presumably carrying out telerobotic activities. Are all secret, but it's you know, we'll find out more about that. So let's look at some latency. Okay, latency has to do with the time delay. Okay, and it's based on the speed of light. Okay, so if you see, you know, you look at what you want to see is something under 500 milliseconds. All right, and you'll see that pertains to a window of 75,000 kilometers, and I'll explain more about that in a minute. But okay, so we have already this going on: telerobotic surgery, mining operations, undersea telerobotics. Here is something really interesting. Earth to Moon. If we do it telerobotically, it takes 2.6 seconds. You know, for you to do something and to see something going on. That is way too long. Way too long. It will take you 10 minutes to tie a knot if you do it from the Earth. Okay, Earth to Mars, it's even worse. Oh my God. 8 to 40 minutes, depending on where they are in the orbit. Okay, but telerobotic operator on Earth controlling spacecraft in LEO, MEO, which is middle Earth orbit, GEO. What we're looking at, because GEO is only 36,000 kilometers, that's under 75,000 kilometers, guess what? The latency, communication latency is less than 400 milliseconds. Cis-Lunar halo orbit, controlling lunar surface telebot, around 400 milliseconds. Okay, huge advantage, huge advantage. Operator on Phobos or Deimos, same situation, under 400 milliseconds. All right, here's something that's finally, you've seen the movie Gravity, and probably, who hasn't seen Gravity yet? Oh, God. You gotta go see it.
The shame.
Yeah, you really have to go see it. This is the first time I think it's in the public consciousness that space debris, it can really screw things up. Okay, now there's some mistakes in it. You're not going to see something going relative speed of 20,000 miles an hour. You're not going to see it like you see it on this screen. But it really makes the point. It's really an exciting movie. There's other mistakes, but still. So we have this terrible problem, okay? Did I bring my marble? Yeah, I did. Got a marble here. Okay, so we have 22,000 pieces of debris larger than 5 centimeters being tracked by the U.S. Strategic Command. 500,000 of those pieces are between 10 centimeters and 1 centimeter. Okay, so the size of a marble down to and smaller. You have tens of millions of pieces, and this debris is on the verge of a Kessler chain reaction cascade. It's called a Kessler syndrome, but it's an uncontrolled chain reaction of collisions that will lead to uncontrolled growth of debris. So how did we get into this mess? And by the way, this threatens a lot of, we'll get to that slide, but it threatens a lot of our way of life. Well, before China purposely destroyed their weather site, actually there were both the Soviet Union and the United States purposely destroyed some satellites, creating debris. But these last two collisions were really contributed at least 1/3 of the space debris, and those are China in 2007 purposely destroyed a weather satellite, and in 2009 a zombie, that is a dead Russian Cosmos satellite, collided with a US Iridium-33 satellite. 1/3 of all this space debris comes from just those 2 collisions. What is at stake? Basically, what is at stake is our way of life, our modern industrialized way of life. So we're all stakeholders, and we are now in a pay now or pay dearly later situation. What is at stake? Cell phones, ATMs, GPS for all kinds of travel, military communications, TV and radio programs, communications for cruises, airplanes, weather reports, spy satellites. I mean, this is an incomplete list. You could go on and on. Okay, but besides being a threat, could it be a resource? Could it be a resource to expand the cis-lunar econosphere? So, well, what is threatened is a $200 billion cis-lunar satellite economy, okay? But this, I think, could pave the way to commercial asteroid and moon mining. The idea is to telerobotically remove space junk for stakeholders before an uncontrolled Kessler chain reaction occurs. There is a company that is trying to do that right now. Well, it's a project, Swiss Clean Space One, low Earth orbit project. It's a public, all of these that I'm going to be talking about, Clean Space One, DARPA's Phoenix, and so forth, they're all public-private projects. Okay? So you got the Clean Space, the Swiss Clean Space One. You've got DARPA's Phoenix geosynchronous and geostationary project. You have telerobotics involved also in MDA. What is that? McDonald, Detwiller, and Associates, a Canadian space company. So that's, the market is estimated to be between 3 and 5 billion a year. Here's Clean Space One's idea. You see the little grabber there? I'll give you a chance to look at it. Okay, that's to remove objects. And there are other ways to do it. You can use lasers and so forth, but those can be problematic too. Recycling. Here's the Phoenix satellite program. Their idea is to repurpose. You know, you have a commercial satellite go up and you get one of those little mini satellites to go up with it. You got a tender in space that grabs it, sticks it onto a dead or zombie satellite that's still got good either antenna or arrays, solar arrays, and bang, you got a new satellite there at a fraction of the cost. That's the idea. And here's MDA. They call theirs the Space Infrastructure Servicing spacecraft. Their Intelsat was actually for a while had an agreement with them, but they were looking for another partner, and time passed. They didn't get the other partner, so it's on hold right now. There's also another project called Vivisat. Okay, and this would not be doing fuels. Here you have Detweiler, the MDA Cis spacecraft actually putting, you see here, fuel tank, actually